what can be done over here. Okay, if R is a point on the line segment joining the point this and this, then prove that x plus y is equals to a plus b. Any idea what to do over here? Yeah. How can we prove x plus y is equals to a plus b? Let me draw for your like so that you can think about it. So R is a point on the line segment. There is a line segment where we are having PAB and a point Q is there whose coordinate is given, and R is a point somewhere on this line segment whose coordinate is given as a xy. So we have to prove this. So let's say this R is dividing this line segment internally in the ratio k is to 1. All right. Let's say like we are assuming it that let's say it is the point whose coordinate is xy. It is dividing the line segment PQ in the ratio k is to 1. We don't know what's k. Okay. Now internally it's dividing. That's what we are taking. Now we know there is a formula for internal. What is the formula for the coordinate when a point is dividing internally in a ratio m is to n? What's the formula for that? Anyone? Yeah,
What's the M1, M2 formula?
yeah,
The section formula?
yeah, the section formula.
M1 for the x coordinate, it is M1 x2 plus M2 x1 by M1 plus M2.
mx2 plus n x1 by m1 plus m2. Like this, Jaslyn.
Yes, ma'am.
And y will be the same way. Let's write it same way. M by 2 plus n y1 by m plus n. So from here, what are we getting? Ka plus b only divided by k plus 1. And from here, what are we getting? From the first one, x is equals to k into b plus a divided by k plus 1. Now let's simplify it more. So we can have over here kx plus x is equals to kb plus a. If we will keep k on one side, so kx minus kb is equals to a minus x. If we will take out k common, basically we wanna find the value of k, like we wanna keep k on one side. Okay, we want to isolate k. So we will be keeping k on one side. For that we are taking k as a common factor and x minus b, and here we are having a minus x. So basically we got k is equals to a minus x by x minus b. Similarly from the other case also we are going to find k in terms of y. Let's do that. So we will be having ky plus y is equals to ka plus b. So k we wanna keep on one side. Ky minus ka is equals to b minus y. Here we will be taking out k common. So y minus a is equals to b minus y. And k will be b minus y by y minus a. Now let's compare both the k's. Okay, from equation number 1 and equation number 2, because k is something we have assumed by ourselves. So we want to get rid of that. Okay, so a minus x by x minus b, the first equation k value will be equals to the second equation's k value. b minus y by y minus a. Let's simplify it and let's see what exactly are we getting. So we will be having over here ay minus a square. Okay, let's are you getting it, or I'll keep on one side and then I'll do the multiplication. What we wanted to prove, x plus y is equals to a plus b. Okay, so a minus x we will be multiplying with y minus a, and similarly b minus y we will be multiplying with x minus b. Let's see what exactly are we getting. Okay, so from here, just a moment, let's open it by applying distributive property. So we will be having ay minus a square minus xy plus ax. And on the other side, if we will apply the distributive property, we will be having bx minus b square minus xy plus by. Is it clear so far? Okay. So here I can see minus xy here, and they are also minus xy. So eventually both will cancel out each other if you will keep both of them on one side, right? So this one and this one will cancel out each other because both are negative. One is on the left hand side, another is on the right hand side. So when you will keep them on one side, they will cancel out each other. However, you need to show it properly. So we will be having ay minus a square plus ax is equal, let's take everything on one side only. So minus bx plus b square is equals to 0. Okay, by also is there. So minus by is also there. Bx, b square, by, everything I have taken is equals to 0. So how many terms are there? 1, 2, 3, 4, 5, 6. 6 terms are there. Let's try to factorize it. Okay. Let's try to factorize it. Let's try to take the common factor. So a square and b square. Let's keep both of them together. So we will be having b square minus a square. I'm keeping it together. Now, what else? ay and by, let's keep them together. Why we are going to keep ay by together? Because this one will give us b plus a, b minus a. So same pattern we are going to make, so that every term will give one of the factor as a b minus a or b plus a. That's why ay by I am going to keep together. So we will be having plus ay minus by, and ax bx we are keeping together. So plus ax minus bx is equals to 0. So let's factorize each and every pair. We will be factorizing this one also. We will be taking out common factor from each pair. Okay, so let's do that. We will be having here, this is b plus a and b minus a. All right, b plus a, b minus a. Other one will give, if we will take out y as a common, we will be having a minus b. And if we will be taking x as a common, we will be having a minus b. So each and every term is giving a minus b except the first one. But yeah, however, we can make the first one as a one of the factor as a minus b by taking out minus as a common. So let's take minus common from the first factors. And then this will also be a minus b. Okay, plus y plus, okay, all the term we need to write now. Y a minus b plus x a minus b is equals to 0. So we will be having a minus b as a common factor, and let's write the remaining term, that is negative b plus a plus y plus x is equals to 0. Okay. Now what we wanted to prove? We wanted to prove that x plus y. So whenever we are having this type of factor in the quadratic equation chapter, you have seen whenever we are having x minus 1 and x minus 2 is equals to 0, what we say, either this one is 0 or this one is 0. Either x minus 1 will be 0, which will give us x is equals to 1, or x minus 2 will be 0, which will give us x is equals to 2. So here also we will be taking two cases. So the first case will be either a minus b will be 0, or the other case will be the other curly bracket term will be 0. So negative b plus a plus x plus y, this will be 0, and this one is giving us that x plus y is equals to a plus b. This is what we wanted to prove. Case 1 we don't want to prove, so we are done with the proof. Can you see it? X plus y is equals to a plus b. So let's summarize what we did. Okay. So if R is a point on the line segment, R is a point on the line segment joining the point P and Q. So we have drawn a line segment where one of the endpoint is having coordinate having point P. Coordinate is also given. Another point is Q, and there is a point R which is sitting on this line segment. So we are saying, let's say this point is dividing this line segment PQ in the ratio k is to 1. Now we are using the section formula. Okay, it is dividing it internally in the ratio k is to 1. We don't know what's k. K can be 1, k can be 2, k can be 3, k can be 2 is to 3 also. Okay, 2 by 3 also. The value of k can be 2 by 3 also. The value of k can be any whole number, it can be any fractional number. Okay, so that's how we are taking the k value. We are keeping only one variable rather than keeping two variables, m and n, k and p, like k and any other variable. We are keeping only one variable. Let's say k. K can be anything. K can be a fraction, k can be a whole number, k can be anything. If we are getting, if k is a fraction, if k is a fraction, let's say k is 2 by 3, then k is to 1 will also be a fraction only. So we don't have to worry about any other thing. Okay, two variable, we are just avoiding that case. Then we are just using the section formula, and then we are writing both the cases in terms of k, and then we are comparing it. After doing the comparison, everything is all about simplification. Can you see it? Are you getting it?
Yes, ma'am.
Okay, let's move ahead. Okay, point P, again from one of the question from coordinate geometry only, which says that point P divides the line segment joining the point A and B such that AP over AB is equals to 1 by 3 if P lies on the line 2x minus y plus k is equals to 0. Find the value of k. Okay, let's read it. Point P divides the line segment joining the point this and this. There is a point P, just like a previous question. We are having a line segment A, B. Here the coordinate is also given, that is 2, 1 and 5, negative 8. Point P is dividing the line segment. There is a point P. Okay. if P lies on the line, this line's equation is also given. Okay, 2x minus y plus k is equals to 0, and one more information is given, that is AP over AB is equals to 1 is to 3. This is very like important information which we need to use. From here only we will get the clue to go ahead. Anyone first, let me know that if you are having any idea about this question, how to proceed, how to solve, please let me know, then we will be discussing it together. Any idea?
Ma'am, we can use section formula.
We can use section formula. Obviously we will be using section formula, but before that please concentrate on the yellow part. Is it indicating anything? AP is to AB is given, so AB, can I write it as AP plus PB? AB, AB completely, can we write it as AP plus PB? Can we? What we will be getting from there, if we will be writing this AB with the help of AP plus PB, what exactly are we going to get? Yes, we will be using section formula, but we don't know here what is the ratio. Here also we will be taking K. Let's see. So the yellow part says AP is to AB is given as 1 is to 3. If we will be taking AP and AB, I want to break it. So AB, I am going to write AP plus BP or PB, whatever, is equals to 1 is to 3. Now let's simplify it further. Okay, by doing crisscross multiplication. So we will be having 3AP over here, and here we will be having AP plus BP. So 3AP and both the AP I am going to keep on one side to do the calculation. So 3AP minus AP is equals to BP, which gives us 2AP is equals to BP, which gives us AP over BP is equals to 1 is to 2. Can you see? We got the ratio and we can use the section formula very easily. Are you getting it? Can you see it? This one. AP is to BP, we ended up getting 1 is to 2 just by breaking it. Is it making sense to you? Everyone, do let me know. Are you getting it? So far, is it clear?
Yes, ma'am.
Okay. So 1 is to 2 we got the ratio. That is AP is to BP is equals to 1 is to 2. This is 1 is to 2. We are saying, let's say the coordinate of P is x comma y. And let's find the coordinate of P. How? By using the section formula. Okay, please let me know what are you getting as a coordinate of P. Find it. Everyone do it on pen and paper, and do let me know what is the coordinate of P by using section formula. Yeah, what are you getting? The coordinate of P? Yeah, Samina has already done and she has got 3. Coordinate of P is 3, 2. Okay. Anyone? Have you got the same? Is it 3, comma 2? Yes, that's correct, Samina. It will be 3, 2 only. Let's uh, let them do. Everyone getting the same?
Yes, ma'am.
Okay. So we have got the coordinate of P as, just a moment. Okay. So let's continue. We have already got the coordinate of P. The coordinate of P. P we have got as 3, comma 2. Let's see what exactly the question says. If point P divides the line segment, this AB, such that AP is to AB was given. If P lies on the line, if P lies on this line, so if P lies on this line, is it possible to find the value of K from here? Yes, yes or no? If P lies on the line 2x minus y plus K is equals to 0, so is it possible to find the value of K from here?
Yes, ma'am.
Exactly. You know P lies on this line and the coordinate of P is 3, comma 2. So X coordinate is 3, Y coordinate is 2. Once we will be substituting the value over here, we will end up getting the value of K. So we will say since P lies on 2x minus y plus k is equals to 0. Hence this point will satisfy this equation. And since it will satisfy this equation, we can substitute the value 2 y is 2 plus k is equals to 0. So we will be having 6 minus 2 plus k is equals to 0. So here we will be having 4 plus k is equals to 0 and k value we got as a negative 4. That is the value of k. So this was quite simple. What we did, P lies on the line segment given. AP is to AB. It was given in a confusing way. But if you will break it and solve it, eventually we will end up having the ratio. Okay. AP is to PB. Once we got the ratio, then we can apply the section formula and then we can get the coordinate of P. Once we are getting the coordinate of P, then we can easily find the value of K. All right. Is it clear? Okay, let's move ahead. So the next question says, D is a point on the side BC of a triangle ABC such that angle ADC is equals to angle BAC. Prove that CA square is equals to CB times BD. Yeah. So D is a point on the side BC of triangle ABC. Let's draw the triangle. Okay. It's not given in the question. So we are having a triangle ABC. A, B, C, and D is a point on the side BC. D is somewhere here. Okay, on of a triangle ABC such that angle ADC and angle BAC, angle ADC. Let's join this to this angle and BAC. This green angle. Okay, this green angle and this green angle both are same. We have to prove that this one. How can we do so? Any idea? Yeah, how to do so? Yeah, any idea how to do so? Yes, Jasleen, Samina, Kiran, any idea? Whatever you are thinking, please tell me. Okay, it can be right, it can be wrong, no worries. Please let
Yeah,
me know. Yeah,
to prove the triangle is concrete, that is the I can't see the triangle.
can you see now?
Yes, ma'am. We have to prove that A, B, and A, D, C is similar.
Yeah, that's perfect. We have to prove that triangle ADC and triangle BAC or whatever you say, these two triangles are similar triangle, and then only we will end up getting this one. How we will be getting this one? Once we will be proving these two triangles are similar, then we will be writing the ratio of the sides which are in proportion with each other. Okay, that expression once we will write, we will end up getting this one. So let's see how to prove these two triangles are similar. I'm talking about ADC and BAC. BAC means complete triangle and ADC means that part only. So here can you see angle C is common in both the triangle. Both the triangle is having angle C. The bigger one and this smaller one ADC. Both are having angle C. So we can write angle C is over here. Angle C is over here only. Both are like common angle. We can also say the given condition, that is ADC and BAC are same. So angle ADC over here is equals to angle BAC over here. That is already given in the question. So we can say angle similarity rule says, okay, that these two triangles are similar. So therefore triangle ADC is similar with triangle BAC. Since these two triangles are similar with each other, now we can write the sides in proportion. I have always said to you that please write the name properly, then only you will be able to write the proportions properly. Okay, so names, how you will write the name properly? So C and C are same, so C must be sitting at same place. Both the C I have written at the edge. Here D, here A are same, so both the D and A I have written in the middle. This is how we will maintain the sequence, and then you will get the name of the triangle properly. Once you will be getting the name of the triangle properly, then it will be very easy for you to identify how to write the sides which are in proportion with each other. So now let's write the sides which are in proportion with each other. AD is to BA. Let's write it. AD is to BA is equals to DC is to AC. DC is to AC is equals to AC is to BC. This is how we will be using the name. And if your name is not correct, whether you are talking about congruency or similarity, if you name the name you have written that is not correct, then this proportion part you won't be able to write. You will end up getting confused. Okay. So what we wanted to prove, CA square is equals to CBBD. CA, where is CA? Here I can see it. So this ratio obviously we need to take, and BD also we need. So BD, where is BD? CB is there. I can see. So let's see whether these two ratio are giving, whether these two green ratio are giving us anything or not. So DC BC is equals to AC AC. So we got CA square, we already got. What about the other part? CB into BD. DC into BC we are having. Let's see what is DC BC. DC and total BC. So BC we can write as BD plus DC, but here plus is not there. So BD square plus BD times CD. From here, from this two ratio, we are not getting AD. Have we taken the proper sequence? Let me check. BAC. AD is to AB is equals to CD is to AC is equals to AC is to BC. Yeah, we have taken the sequence properly. CTAC and AC. Okay, yeah, we are already, I think I have noted it down in a wrong way. What is it was asking? CB and new, okay, this was not BD, this was CD only. Yeah, so we are done with the proof. CD and BC. Okay, can you see it? BC and CD over here, and we have already got the same, no need to do anything extra. From the ratio itself, we have got the proof, okay? So we can write it, CA square is equals to CB into CD. CB means BC, it's the same thing. We can write CB into CD. DC, CD is the same thing. So we are done with the proof. Any doubt over here? Yes, do let me know. Any doubt? Okay, let's move ahead. So whenever this type of proof is given, just go ahead and prove the similarity. You will end up getting the proof, whatever it is asking. Okay. Okay, now the next question is from trigonometry. Let me write the question. So the question says, from a top of a 7-meter high building, the angle of elevation of the top of a cable tower is 60 degree, and the angle of depression of its foot is 30 degree. Determine the height of the tower. Okay, from a top of 7-meter high building, the angle of elevation, yeah, of a top of a cable tower, okay, is given as 60 degree, and the angle of depression is given as depression of its foot. Okay, cable tower is there and there is a foot of the cable tower, and that's angle of depression of its foot is 30 meter. Find the height of the tower. Okay. So from the top of a 7-meter high building, so if we are having a 7-meter high building like this, from the top of it, all right, from the top of it, angle of elevation of a top of a cable tower. Now there is a cable tower also. There is a cable tower also like this. Okay, this is cable tower. An angle of elevation of the top of the cable tower is 60 degree. Like this angle of elevation you will be taking like this. This is 60 degree. Now let's see what the next information says. And the angle of depression of its foot, it's 30 degree. Yeah. Okay. So here it says that from the top of 7-meter high building, the angle of elevation of a top of a cable tower is 60 degree. We have drawn it accordingly. That is cable tower. This is the building. Now it says that and the angle of depression of its foot. So this, the top of the building is having the angle of elevation and the foot of the building is having the angle of depression. Wait just a minute, is it saying so, or is it talking about the depression of this tower? Angle of elevation of the top and the angle of depression of its foot. So if we will be taking angle of depression, we know depression means going down like this. This is the angle of depression. Okay. Top of the cable tower, it is elevation, and foot of the cable tower, it is depression. That is given as 30 degree. Now what we have to find? We have to find the height of the tower. This is the complete figure. Just let's go through it. Okay. From a top of a 7-meter high building, the angle of elevation is there and the angle of depression is there from the top only. One, from the top we are going angle of elevation to the top of the tower, and angle of depression we are taking to the foot of the tower as it is given in the question itself. We have to find the height of the tower. Okay, the total height of the tower we have to find. This much height of the building is 7 meters, so we can say this much height of will be 7 meter only, and the remaining height will be h. Okay, this is what we can say. This is the overall information we are having in hand. We have to find the height of the tower. That means we will be finding h, and then h plus 7 total we have to find. Okay, so any idea what to do over here? Please let me know. The figure we have plotted it. Main thing in this chapter is to plot the figure. If figure is given, well and good, or you are all sorted. If figure is not given, so then carefully you have to plot the figure. Okay, I have drawn the figure. Now tell me which trigonometric ratio will help us to find the value of h from here. Let's name it A, B, C, D, here also E. Yeah. Now tell me which trigonometric ratio will help us. Any idea? Yes? Any idea what to do over here?
When we can find,
Yeah, tell me. Yeah.
is it possible to find
Is it possible to find what?
AE,
A, B,
distance AE?
AE. No, that is not given. Yes, but that is possible because here we will be getting two cases. Okay, if you can see one of the triangle, let me show you. Two cases you will be getting, and yeah, with the help of both the cases, I believe we will be able to reach whatever we want. This is one of the triangle, and I wanna say the other triangle is this one. But if you are asking what is the angle over here, then you must know that if that is 30 degree, this will also be 30 degree.
30
Okay.
degree.
So two cases we will be getting from here rather than only one case and solving it straightforward. We will be getting like if we will be taking triangle ABE, we will be getting like H and X we can use. So which trigonometric ratio will help us to use H and X? And triangle ADC. Here also we want to use 7 meter and this X. This is also X only because the parallel line we have drawn. Okay. Now tell me which trigonometric ratio we'll be taking for the green triangle. This is I can see is perpendicular and this is like this is opposite side and this is adjacent side. Opposite and adjacent I want to use over here. Then which trigonometric ratio?
Tan 60.
Tan 60 is equals to opposite over adjacent. Here A ADC. Here also what we want to use opposite and adjacent only. So tan 30 is equals to 7 over x. Oh yeah, here it is possible to find x. Can you see? What is the value of tan 30? Yeah, what's the value of tan 30? Yeah, okay. Yes, Samina, we can use tan 30 and tan 60. Yeah. What is the value of tan 30? And what is the value of tan 60? You have learned that, right? Tan 30 1 by root 3. Perfect. So 1 by root 3 is equals to 7 over x. And from here we got the value of x as a 7 root 3. Okay, meter, centimeter, whatever is given. Now once we got the value of x, that value of x we can substitute it over there to get the value of h. But be careful, we don't have to find h. We have to find the total length, 7 plus h. Okay. Is it okay? Let's summarize the whole concept. What we did exactly. Main thing was plotting the figure. So from the top of a 7 meter high building, From the top only everything is happening. Okay, this word is very this is the most like keyword which you can see in this question. This is the keyword, that from the top of a 7-meter high building, from the top only angle of elevation, from the top only angle of depression. Okay, so from the top of a 7-meter high building, the angle of elevation of the top of a cable tower is 60 degree. So there is a cable tower. From the top of a 7-meter high building, we are drawing the angle of elevation. As we know, elevation means it will go up. Okay. And the angle of depression. So from the top of a 7-meter high building only, the angle of depression will be 30 degree. Okay, angle of depression of its foot means the cable tower's foot. Okay, the instead of its, if it will be written cable tower here, no, it will make more sense, but since it's written its, so we will be just going, just before that we will be seeing like which cable tower is mentioned or the building is mentioned. Just like in English sentence, the paragraph, wherever he or she is mentioned, just we go before that and we check whose name is mentioned over there. So which person's name is there, that is like that he or she is for that person only. Here also its means the cable towers. The cable tower's foot is 30 degree. Angle of depression of cable tower foot is 30 degree. Determine the height. Accordingly, we have plotted the figure and we are just doing the calculation. This type of calculation you have done a lot of time while doing that chapter at the application of trigonometry and all, where easily you few questions were there where it was not possible to take out the value in one go only, so you have to work on that, maybe 2 3 equation, and then you were getting the value. This is that type of question. Okay, now let me take a simple question. Okay, a very basic question I am taking. You tell me what to do over here. A quadratic equation is 4x square minus 5 is equals to 0. We have to find the nature of the root. Nature of the roots. What will be the nature of this root of this quadratic equation? What to do over here? It's there in your syllabus, right?
Oh, yes, ma'am. We can use, first we can find the discriminant and see if what we got is greater than 0 or not. If it is, then we have to find the roots as well.
What is the discriminant formula?
Under root b square minus 4ac.
Is it under root b square minus 4ac?
No, ma'am. B square minus 4ac.
Yes, it is b square minus 4ac, but root is not there. Root is there in the quadratic equation formula where we were having minus b plus minus root b square minus 4ac by 2a. That formula we were having root. But here for discriminant, it is just the b square minus 4ac. So what is b value over here? B, what is b over here? Anyone? What is b value? If we will be comparing it with ax square plus bx plus c, what is b value? B is not there. It's 0, right? If we will be comparing it with ax square plus bx plus c is equals to 0, the general form. So b we don't have, right? So b value will be 0. What is a and c?